First example, prove that normals from alpha, beta and gamma to the paraboloid x square by a square plus y square by b square equals to 2z lie on the cone alpha by x minus alpha minus beta by y minus beta plus a square minus b square over z minus gamma equals to 0। आपको शो करना है कि नॉर्मल्स फ्रॉम अल्फा बीटा एंड गामा पैराबोलॉइड पे अगर लाई करते हैं तो इक्वेशन फॉर्म आपके पास क्या होनी चाहिए ये। फर्स्ट ऑफ ऑल हियर द इक्वेशन ऑफ अ पैराबोलॉइड इज ax square plus equation of paraboloid is x square by a square plus y square by b square equals to 2z, and this is passes through a point alpha, beta and gamma, and from these points the equation of a line is x minus alpha over L direction cosines, y minus beta over m and z minus gamma over m. Okay, and here I am supposing that because of prove that you have to show that ki normals from a alpha, beta and gamma to this paraboloid lie on this a paraboloid, then it is of the form. So for our normals, here the equation of a plane passes through the alpha, beta and gamma, and this equation is of the form x minus alpha over L, y minus beta over m and z minus gamma over m. Now normal at I am taking here 3 points x1, y1 and z1 because of a normality at x1, y1 and z1. ठीक है, but here paraboloid is of the form, then if you have to find out the equation of a normals according to the point alpha, beta and gamma. For the normal, firstly you have to see that about the equation of a tangent, and from this equation at a point x1, y1 and z1 the equation of a tangent is of the form x1 over a square plus y1 over b square plus equals to z plus z1. So x1 by a square plus y1 by b square minus z equals to z1. And here coefficient of x is x1 by a square, coefficient of y is y1 by b square, and coefficient of z is minus 1. So these direction cosines Lmn are proportional to the coefficient of x, y and z, and the coefficient of x is x1 by a square, y1 by b square, and the coefficient of z is minus 1. So these vectors, these values are proportional to Lmn. And if two vectors are proportional to each other, say suppose k is a proportional to p, this is a sign of proportional. If k is a proportional to p, then k is a some scalar multiple of p. If L, M, N are proportional to these vectors, these values from coefficient of from the equation of a tangent, coefficient of x, coefficient of y and coefficient of z, L, M, N are proportional to these. So L equals to some scalar multiple of x by x1 by a square, m equals to some scalar multiple of y1 by b square, and n is equals to some scalar multiple of minus 1. Okay, you have L, M and n. But in a last lecture we discussed about the normal of paraboloid. In this case you define a three vectors. Here we take a three vectors x1, y1 and z1, and these coordinates are x1 is a square alpha over a square plus beta, y1 is b square beta over b square plus lambda, and z1 is gamma plus lambda. Use these three vectors. So x1 is L equals to k by a square, and the value of x1 is a square alpha over a square plus lambda. M equals to k by b square beta over b square plus lambda, and n equals to minus k. Okay. Now L is k alpha k over a square plus lambda. M equals to beta k over b square plus lambda, and n equals to minus k. Now a square plus lambda equals to alpha k, b square alpha k by L, b square plus lambda equals to beta k by m. Okay, subtract these equations. A square plus lambda minus b square minus lambda, a k over L minus b k over m. A square minus b square equals to, take k common, alpha over L minus beta over m, and the value of k is minus n. Substitute here, minus n alpha by L minus beta by m. A square minus b square equals to minus L alpha by L minus beta by m, and from this equation the value of L is x minus alpha, value of m is y minus beta, and value of n is z minus gamma. Substitute here, you have a square minus b square equals to z minus gamma alpha over x minus alpha minus beta y minus beta. Z minus alpha, a square minus b square over z minus gamma minus alpha over x minus alpha plus beta over y minus beta. And we have alpha over x minus alpha minus beta over y minus beta plus a square minus b square over z minus gamma equals to 0. ठीक है, और आपको शो भी यही करना था कि मेरे पास अगर कोई भी इक्वेशन है पैराबोलॉइड की तो फॉर्म आपके पास क्या होनी चाहिए, इफ़ अल्फा बीटा एंड गामा लाइज ऑन द इक्वेशन ऑफ अ नॉर्मल देन दिस इज ऑफ द फॉर्म. Prove that normals from alpha, beta and gamma to the paraboloid light on the cone is of the form alpha x minus alpha minus beta y minus beta plus a square minus b square z minus gamma equals to 0. See, next example is find the equation of the plane cuts the paraboloid x square minus 2y square equals to z in the conic with its center 2, 3 by 2 and 4. Here you have a 3 chords x1, y1 and z1. If the find the equation of a plane, आपको प्लेन की इक्वेशन फाइंड आउट करनी है जो कट करता है पैराबोलॉइड को किस पॉइंट पर. सो फर्स्ट ऑफ ऑल इफ एनी plane section cuts the paraboloid is always of the form t equals to s1. We already discussed it by. कुछ नया नहीं है ये, पहले ही इस बारे में बात कर चुके हैं कि इफ एनी पैराबोलॉइड, इफ एनी कॉनिक सेक्शन इट्स कट बाय एनी प्लेन सेक्शन then this equation is of the form t equals to s1. And here the equation of a paraboloid is of the form x square minus 2y square equals to z. T is the equation of a tangent, and equation of a tangent is x1 minus 2y y1 minus z plus z1 by 2 equals to x1 square minus 2y1 square minus z. Now here the coordinates are 2 minus 3 by 2 and 4. 2, 3 by 2 and 4. Substitute here. 2x minus 2 into 3 by 2 y minus 1 by 2 z plus 4. x1 square 2 square is a 4 minus 2 into 9 by 4 and minus 4. 2x minus 3y minus z by 2 and minus 2 equals to 4 minus 9 by 2 and minus 4. Take 2 LCM. So we have 4x minus 6y minus z equals to plus 4 and minus 9. 4x minus 6y minus z equals to minus 5. 4x minus 6y minus z plus 5 equal to 0. This is a plane section which cuts the paraboloid at 2, 3 by 2 and 4. Next example, find the locus of the point of intersection of three mutually perpendicular tangent planes to the paraboloid. In this exercise, your first article is depend on this topic, three mutually perpendicular tangent planes of the paraboloid, and this example is same as your article, and the article number is that's one. To find the locus of a point of intersection of three mutually perpendicular tangent planes to a paraboloid, and here the equation of a paraboloid is ax square by square equals to 2z, and in this example the equation of a paraboloid is x square by a square plus y square by b square equals to 2z. And for making this equation as a articles form, then take c a square plus y square by b square equals to 2z by c. Take c as a LCM, then you have as a multiply both side by c, or as a LCM x square by a square into c plus y square by b square into c equals to 2z. Here I am multiplying both sides by a c. Now this equation is become of the form ax square plus by square equals to 2z, and here the value of a is c by a square, value of b is c by b square, and the 2z and 2z both are the similar, so don't take any coefficients like this. Okay, this is the same as your article number 9.23. Try it yourself. If you have any doubt, then you may ask.